Satyajit Sinha. I'm a principal analyst from IoT Analytics. We are a market intelligence provider and we provide market intelligence to IoT community. Today we're going to discuss the LoRa and Mesh network technology together, and it will be very interesting to understand what is the state of this technology and what are the updates. Today we have an interesting panel, and we'll let them introduce themselves.
Yes, hello, my name is Thomas Halkier. I'm CEO of NeoCortec, a company who's been doing wireless mesh network protocol stack for more than 10 years now, and we recently introduced our solution on the LoRa physical layer.
Hello, my name is Thomas Göttgens. I'm Vice President of Meshtastic Solutions Incorporated. We've been a company for more than 1 year now. Previous to that, it's been an open source project, so it's still an open source project. So this is a sister company to the existing open source project. And we've been doing a mesh network on the physical LoRa layer for 5 years now.
Great, thanks. We can start with, I want to ask a question to both of you to understand what it means, adding mesh to LoRa, and what is the biggest difference that you see today when you add mesh to a LoRa, and if you have examples or deployment of it, that will be interesting to understand. Yeah.
Yes, okay. The biggest difference, I think, is you don't need the infrastructure. With LoRaWAN, the classic system that you would use with the LoRa physical layer, you would have the gateway that gets the packets that talks back to the sensors. And with the mesh networks, you have a peer-to-peer network. Of course, you can set up gateways, you can set up repeaters, but it's not mandatory to operate the network. You can just deploy 3 devices and they will build an ad hoc network on the field.
Yeah. Thomas?
Yeah, I completely agree. I think it's that ability, and then also it opens up actually for some other application, or maybe makes some application easier to access.
Yeah.
So one of the things that we are seeing in particular is, for instance, mining, deep indoor, forest applications where you will benefit from the longer range of the physical layer of LoRa. Where in the mesh, but if you had to do it with LoRaWAN, then you would need to then figure out a way to deploy gateways across the site.
Makes sense. But what are the real world challenges or constraint that comes with this combination that you're doing with mesh plus LoRa? And is it coverage, latency? If you can give sharing some examples of it, it would be good. Yeah.
Yeah, I mean, for us at least, is that as a nature, a mesh network is different from a star topology network like LoRaWAN, where in a LoRaWAN network, each device only has to take care of himself. So whatever he transmits, it's on his own part. Yeah. Whereas in a mesh network, the devices will be doing some activity on part of the others. And this means that the overall activity from each device will increase, and then that provides challenges on duty cycle limitations. It provides challenges on current consumption. So,
yeah, Thomas.
Yeah, this is. I think this is the main difference and the main challenge for a mesh network, because in our case, the Meshtastic stack is not really tightly time synchronized, because there's a lot of different devices and a lot of different MCUs, and you can't always get the timing right so that the devices can sleep and wake up on a common schedule. So it's more loosely coupled than you would have with a LoRaWAN network, and the airtime, the duty cycle, and also the limitations on the frequency where there are other users as well, and they produce interference. This is the main obstacle that needs to be overcome. Yeah.
Makes sense. Thomas, for you, in past 1 year, how NeoCortec added the LoRa physical layer to its NeoMesh protocol stack, and how does this change the opportunity for NeoMesh and for your customers?
Yeah, for us, being in the market for more than 10 years now with meshing on regular FSK radios, one of the things that we saw was that in many cases the range is not so much limited by sensitivity, more so by noise in the environment. And this is what LoRa does really well. It does give you the ability to demodulate signals in a noisy environment much better than the simpler modulation scheme. So what we are seeing is that we will enable some applications to work better on the LoRa physical layer. For instance, consider a vertical like smart building solutions, one of the things that we are now pushing is actually solutions on 2.4 gigahertz,
Okay.
which normally on FSK we wouldn't be doing because obviously, as everybody knows, there's a lot of things happening at 2.4. But with LoRa,
Yeah.
we actually see that we get similar range indoor on 2.4 as we get normally at the sub gigahertz. And obviously, 2.4 being a global frequency band makes things a lot easier.
Great, great. You want to add something on that top of that? Okay. Then for your perspective, where are you seeing the adoption, and if you have any use cases from top of on your mind, it would be interesting to understand.
Yes, of course. Meshtastic started out as a communication network. The initial use case was hiking and paragliding, but then again it evolved from there. And we see a lot of requests from even from professional customers to go more into telemetry, sensor networks, and all kinds of stuff. And the applications really they come with the customer because we would never have thought of some of the applications that they propose to us, and our job is mainly to channel those and make them happen or tell someone it can't happen. So yeah, we see the need is there for some kind of these protocols on a peer-to-peer layer to break out of this classic hub and spoke mechanism. And for instance, we have one use case at the moment. We're working with the Smart Citizen Lab in Barcelona. Yeah. They have an existing sensor out that is at the moment using Wi-Fi connectivity to uplink the sensor data to a central server. And we are working with them at the moment to implement a new version of this sensor bank, the version 3.0, that will additionally use Meshtastic as a transport mechanism, so you can deploy a city network of sensors and don't have to provide Wi-Fi coverage all over the city to access the actual sensor data.
Interesting. So in your latest deployments, what are the measurable outcome did you see with Mesh and LoRa deliver? And how do you KPI? What is the KPI to quantify that?
Yes, we've had two big installations in the last half year. One was both were in North America and the USA. One was at DEF CON, where we put up a network with more than 2,000 nodes at the same time, and also invited the people to try to hack it, crack it, compromise it. We've had a few reports coming out of that, and we are processing them right now. And of course, this is for an open source project. This is normal. You can audit it. You can send the vulnerability information in, and we'll make it better from that information. The other one was actually at Burning Man, where we surpassed that number. We had 2,500 people on the mesh there at the same time. Of course, these events, they get a special firmware, special prepared firmware from us that has some certain presets that caters for this dense, highly populated local network. You could not run this kind of setup on a sparse rural network because the range would not be there. This is tuned for capacity, not for range.
Yeah. Thomas, you want to add?
Yeah, I mean, for us, when talking about the success criteria for installations and how to gauge whether an installation is successful or not, one of the things to keep in mind is for our customers, normally it's a low power application. So it would give you a network running maybe 10 years on a battery in an installation. And if you think about something that runs for that long, then lots of things will change over time. So it's not only the concern over the battery. So one of the things that we have in our system is a very, let's say, useful tool to monitor the network automatically on, let's say, the edge side or the gateway side, if you want. So it's an automated tool that will, let's say, take care of the network in a way, look, to see if all devices are still there, responsive, if they have enough neighbors, if the field strength is high enough, and these type of things. And then, if not, it will give you an alert. So I think for us, one of the things that we've been focusing on is alongside the main protocol stack, to provide the tools for the installers and the operators of the network to really have a, let's say, reliable installation that will work for a long duration.
Interesting. Just to understand from a developer perspective or even from a user perspective, from a 2-week pilot project, what is the one acceptable test that makes sure that this is going to scale? And it would be great to have anything from your experience that's KPI which decide that this can be scaled very easily.
Yeah, I mean, it's hard to say really because it's of course you'd need to make a test installation and test it out, and you need to push it to the limits.
Yeah.
One of the tough things for mesh networks usually is high density. So
Yeah.
that's of course one thing you would want to test. But also I think in our experience one of the more challenging parts is that when you have unstable radio links. So when you have something where you have a certain number of CRC errors and you need to do repeat, and even actually the case being that you can have messages that had bit errors even if you do CRC. How do the network actually cope with that?
Yeah.
It's not a guarantee to do CRC. It's only, let's say, a probability for not having bit errors.
Yeah.
So those type of things you need to watch out for and really test.
Thomas, you want to add?
Yeah, we don't have any universal KPIs. It of course depends on the actual implementation or the actual deployment we're doing. Some of the networks, they grow organically because people just buy the nodes and set them up and organize themselves in user groups. Some of them are centrally managed, and usually if someone approaches us to help them set up a network, we will do some initial site planning with the some tools we have for this one. Recommend some points where you can do fixed installations to get a good radio coverage, and then when the network is actually built up, we will do some live analysis on the network. We can have 1 or 2 hour measuring period where we put artificial load on the network to see how it performs and to see where the weak spots are and where we may need to adjust the network parameters or put up an additional infrastructure node to support more bandwidth in the network. But this is an iterative process. We cannot just do it from the drawing board. We need to phase that in and tune the network in, and then we at some point we are satisfied and the customer is satisfied, and then from then on the network with occasional monitoring will run on its own.
Interesting. But from your perspective, when your company will be able to see the growth from to enterprise and public safety use cases, are we planning for that? And how it will achieve that, any strategy behind that?
That's not really a technical problem. That's a psychological problem.
Okay.
Because especially in public safety, there's been a mood for 20 years, 30 years, 40 years now that you cannot run public safety on a public network. So I've been in the business in some other capability for about 25 years, trying to implement text message alerting for firefighters against dedicated systems that use their own radio towers and so on. Of course, there's a price difference between municipal installation and just using some public network, and this discussion has been going on for years, and I think it will still go on for years from now. So you need to just convince the people that are doing the decisions that the technology you have is right for this use case that they have, for the emergency network, for communicating in case of a power loss, and sometimes it may be necessary to move the actual protocol stack from the public frequency to some other frequency that's either allocated to the authorities or that's not on the public ISM band, to provide some kind of reliability to it that the customer is satisfied. That's I think it's the main obstacle to overcome, to give the customers confidence in the solutions you have.
Interesting. Thomas, for you, what's the next tool or element from your stack is coming up in next 6 to 12 months or something which will have an impact for your customers and help the mesh technologies?
Yeah, so one of the things that we are really focused at is, let's say, upper level system integration.
Yeah.
So interfacing with other level protocol stacks, we're looking at IP compatibility, we're looking at DLMS for metering.
Yeah.
So I think those kind of things will help the customer to better use or have an easier way of using the technology. So that's on one hand, and then of course for us, the journey with LoRa is fairly new. I know from Semtech that new things are on, let's say, the horizon, and one of the things that would be a good idea for meshing is to increase the physical layer bitrate, because then you can get the time on air to be lower. So I think we will follow those developments that are happening and push our stack to use those new features and capabilities.
One follow-up for my personally as well, how developer who are interested in testing NeoMesh can access to your technology?
Yeah, okay. So it's a software protocol stack, realizing that just giving a piece of software to the developers is going to be a little bit time consuming to integrate and make work. So we have partners that do modules. One of them is here, Mbit. So they offer a fully integrated certified solution on their module. It has development kits, it has gateway solutions with it. So that's probably the easiest way to come across it. Then of course we also work with integrators and OEMs directly to license the stack for them and their use.
Great. Thanks. Just want to ask one final question from my end to understand. Mesh technology is not a new technology; it's been there for years, right? But technology overall landscape is changing, right? We are adding AI, we are adding security is getting stringent. How do you guys see the mesh technology going to the next phase from here onwards? What are the things that will change, and which applications? That we talked about some of the applications, but which application you think will be the key highlight to understand that this application will take? One also add on, if you can add satellite technologies coming into the picture, how integration of that can if make any changes or not. So just a quick.
You want to start? Okay. Yeah. So I mean, satellite communication, if we start there, is a very let's say exciting topic. It gives you some really nice aspects of being, let's say, independent from any ground stations or anything like this. There is a cost associated with it in terms of power consumption and in terms of antenna sizes and these type of things. So I think a hybrid solution between, let's say, a satellite uplink and a mesh solution that can work on ground or even below ground would be, an interesting thing to do. And we are looking into this. So I think the hybrid between not only the mesh and the satellite uplink, but we are also looking at hybrid solutions between our mesh and the LoRa WAN itself.
Correct.
So I think that's one of the things that we need to explore, but it has to be based on actual application requirements, because we can spend all day coming up with all sorts of nice technical solutions, but at the end of the day, it has to be something that has a place in the market and the market is asking for it. So yeah, I think that's how we see it.
Makes sense. Yeah.
In terms of AI or edge AI, I think the mesh network will be a good solution to facilitate a new type of sensor, because at the moment the mesh does not have enough bandwidth to transmit high resolution or high scanning sensor data over the network. So you cannot have a video signal, or you cannot have, for instance, wind measurements every few seconds, because that would quickly saturate the mesh. But what we can do in the future, we will see some new kinds of sensors that utilize the edge AI that will do the processing on site and just send the results or triggers or events over the network. And then again, the mesh network will very well be suited to this lower kind of traffic, and maybe you have a trained image sensor that says just a dog ran by or a person ran by, and it's kind of intelligent motion sensor, but you don't have to transmit the actual picture to do that anymore. So I see this is a good application in the future for new sensor networks or new sensors on the network.
Interesting. Makes sense. Thank you so much for your time. It was great insights. I hope we all take something from here, and I'm looking forward for the mesh technologies, future upgrades, and looking forward to it. Thank you so much, and thank you everyone for joining.